Conjecture 57, dilation of a polygon conjecture. If one polygon is a dilated image of another polygon, then the polygons are similar. So what we're going to do is we're going to mark this the center of dilation by double clicking on it, and then if you go ahead and highlight the polygon, we're going to go to transform, dilate. In this case, we're just going to set a ratio. So go ahead and pick a ratio. We'll make this 3 times as big. We'll see if it stays on the screen. And it does. And what we have here are 2 similar polygons. Conjecture 58, dilations of circles conjecture. Since one circle can be dilated to transform onto another circle, all circles are similar. And what we're going to do is we're just going to drag this point here to show the ratio. So if you were to take the ratio of BC to the length of BD, you would get this ratio here of 0.39. And you can scale it however you'd like, but you can see if it's a 1-to-1 dilation or a ratio of 1, that the circles would then be congruent. So all circles are in fact similar. Conjecture 59, angle-angle similarity. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. We can show this again by dragging the similarity ratio to a ratio of 1. You can see that the triangles are congruent. As this moves out, the shape is staying consistent, but the sizes are changing. Conjecture number 60, side-side-side similarity conjecture. If the 3 sides of one triangle are proportional to the 3 sides of another triangle, then the 2 triangles are similar. So we want to show that all sides are in the same ratio. So if I match up my corresponding sides, let's go to number calculate. So if I divide the corresponding sides, I will get a ratio that should be consistent amongst all the corresponding sides. And then lastly, the third pair. And you can see that all 3 pairs have the same ratio. So no matter how these triangles move, the ratios will stay consistent. Conjecture number 61, side-angle side similarity conjecture. If 2 sides of one triangle are proportional to 2 sides of another triangle, and the included angles are congruent, then the triangles are similar. So what we have here is we're going to show that the sides are in the same ratio. Okay. And we also have that the angles are congruent. So no matter how these triangles move, we have congruent angles. Those 2 angles are the same. And then the sides are proportional. If that's the case, the triangles are similar.